All right, we're going to be talking about indirect and direct measurements today. So, direct measurement is when you can directly measure a length, like with a tape measure. So I can take my tape measure, I can go to Roy's desk, and I can measure Roy's desk and say, oh, it's 24 inches or 2 feet. That's direct measurement. Anything I could actually walk and measure. You know how they have those little measuring things where you can walk and then it kind of rolls and you can get the measurements on there? Anything that you could directly measure with walking or measuring distances is called direct measurement. Anything on the ground that you could physically, okay, I want to measure this length of this shadow. So you get one person on one side, you're on the other side, and you can measure it. That's a direct measurement. Indirect measurement is when you physically can't measure it with the tape measure. So you use similar or congruent triangles to measure a length or a distance. That means you were not able to physically measure how high something was. The tree is just too tall. I can't get a tape measure to the top and drop it all the way down. It's too big to measure. So you're going to use similar triangles or congruent triangles. Now those, you're not always going to get an exact measurement that way, are you? You're going to have to round it. You're going to have to estimate it a little bit just to see how it works. But you can get a really close estimate, is what they're saying. So in this little mirror example here, are the triangles similar? Why or why not? So here's this little guy right here. His dilemma is that his teacher has given him the task of measuring how high that flagpole is. He can't physically get up there and measure it, so he has to use indirect measurement. So what he does is he takes a mirror, puts it on the ground, anywhere he wants, just puts it on the ground. He backs up until he can see the flagpole in the reflection. So I'm standing right here and I can see the tip of the flag in the mirror. Okay, so he takes that, and then he can measure the distance. He can measure how far away he is from the mirror, and he can measure how far the mirror is away from the flagpole. Those are all direct measurements he could do. Either with him or with somebody else, he could string and he could measure these amounts. And then he knows that he's 4 foot 2 inches tall. So the first question is, are the triangles similar? Do you see two triangles? Are they similar triangles? How do you know? Because the answer is yes. They are similar. So yes. But what we need to do is we need to know why they're similar. Is it AA? Is it SSS? Is it SAS? Those were the three ways that we learned to show that triangles are similar. It's not SAS. It is AA. AA postulates. Let me change this to reds. Let's see the answers a bit better. Okay, it's the AA postulate. Well, let's see why the AA postulate works. Do you notice in the triangles that both triangles have a right angle? Okay, the flagpole is straight up from the ground, that's a right angle. He's standing straight up, that's a right angle. The law of reflection, I put a picture on your little paper there. I wanted you to see it. That's a picture of somebody holding a laser. Like one of those little lasers that you would point somewhere or whatever you try to distract people. Okay, that's a laser. Now the laser's coming in and it's hitting this mirror at 10, 20, 30, 40 degrees from the horizontal. You see that? Now, do you see where it comes off? Do you see where the laser comes off very lightly? That comes off at 10, 20, 30, 40 degrees. So when you bring a laser in and it hits the reflection mirror, it comes off at the exact same angle. That means that these two angles are congruent angles, meaning that these two next to this mirror are congruent angles. So you've got the right angles and you've got the mirror angles. So you've got AA postulate. So they have to be similar. So now let's help this little guy find out how tall this flagpole is. That's X over here. I know you can't see that very well, but you might be able to see. Yeah, you can. So X, we want to find the X. So I'm going to put X over something. What would I want to put X over? What corresponds to the X in the other triangle? 4 feet 2 inches. Let's change it to inches. 4 feet 2 inches would be 50 inches. So I'm going to make the height over the height be my first fraction, my first ratio. Now I need two ratios. I need to set up a proportion to solve it. So what's my other ratio going to be? What's my other two corresponding pieces? I got to put 6'3" on top because I put the H on top, right? So I got to put the 75 inches on top because that's what 6'3" is. And on the bottom, 2 feet 1 inch, 25 inches. 25 inches. I would suggest to reduce in your head if you can. If you can reduce easily, I would do it. Can you reduce 25 over, or 75 over 25? Yeah. Yes, we could actually reduce those to 3 over 1. So if you can reduce it, I would definitely reduce. It's always a smart thing to reduce. Now you can multiply your diagonals. You're going to get 1 times x, which is just x. And 3 times 50 is 150 inches. Can you change that to feet now? How many feet and inches would that be? Remember, think of 12 inches is 1 foot. 12 times 12 is 144. So what do you think? I'm thinking 12 feet 6, or yeah, 12 feet 6 inches. 12 feet would be 144 plus 6 more would be the 150. So that flagpole was 12 feet 6 inches tall. Okay, so indirect measurement, when you use a mirror to help you find an angle, to help you make similar triangles. Now you could also use congruent triangles. You could use, in this case, we're using similar triangles. Let's look at the next example. You could also use shadows. Because when a shadow, how does a shadow get made? It gets made by the sun, the angle of the sun, right? So when the sun is coming down at a certain angle, if your shadow is at the same ending point, then it's going to come down at the same angle. So again, you're going to have the AA postulate that says you have similar triangles there. So a 6 foot tall person, this guy's right here, 6 foot tall. Okay, he's 24 feet from the end of his shadow. So what he decided to do to measure his flagpole, what he decided to do is he decided to stand next to the shadow of the flagpole. So the flagpole's back there, and the shadow is going past him. So he makes his shadow go right to the end of the other shadow. So both shadows end at the exact same place. So now he's got two similar triangles. His triangle with his shadow, and then the flagpole's triangle with its shadow. And those have to be similar because the angle of the sun is going the same when the two shadows end at the same place. So what could I set up as my proportion here? Let's solve for h. So let's put h on top. So h over, now last time we did h over, would be h over 6 because we did height over height. Would it be okay if I did h over 48? Okay, if I did h over 48, what would I have to put for my other ratio? 6 over 24, and that would work. So you could put height over length, and you'd have to make sure your next one was also height over length. You just have to make sure they match up. So that would be h over 48 equals 6 over 24. Yes? And it won't matter as long as you're corresponding. If you do height over height, then you got to do length over length. If you do height over length, you got to do height over length. Because you would, if I used this h over 6, let me just show you what would happen here. If I used h over 6, and then I did 48 over 24, look and see what I would be multiplying together here. In this first one, I'm going to be multiplying h times 24, right? And I'm going to be doing 6 times 48, right? In the second one, I'm going to be doing h times 24 still. And I'm going to be doing 48 times 6 still. It doesn't change what you're multiplying as long as you stay consistent. Height over height would have to be length over length. Height over length would have to be height over length. And then you'll be okay. You just have to stay consistent. So I would reduce the fractions here. So if I was doing this first one, I would reduce 6 over 24 and I'd make it 1/4. Just so I can make it a little easier on myself, 1/4. So that would be 4h equals 48. And then you're going to get h equals 12 feet. In this case, if I reduce this, I would put 2 over 1. For these two, I'd reduce those two, and I just put a 2 over 1 instead, because 48 is twice 24. And either way, this time you're going to get h times 1 is h, so h equals 12 again. So yeah, that might have been a little shorter, but they're both 12 feet. Either way, it's 12 feet. Okay, moving to the back side. There's just a couple left. They're this short today, definitely. Walter is standing next to a professional basketball player. The player's shadow is 2.3 feet long. Walter is 6'3" and his shadow is 2 feet long. So we've got a picture that looks something like this. Let me make a triangle and I'll kind of show you what we've got here. It's a right triangle. It's actually not that long of a shadow. So the basketball player, we don't know his height. But we do know that his shadow is 2 feet 3 inches. Okay, we have another person, Walter, who is a little shorter. He's a little shorter. I know that because his shadow is a little shorter. He's 2 feet 1 or 2 feet shadow. The other guy had a 2'3" inch shadow. And it says Walter is 6'3". So what does that tell me about the basketball player? He's taller than 6'3". Okay, so we know that. So what good proportion could I set up to solve this one? What would I use? X over 2 feet 3. Let's do inches. So that's 27 inches. Okay, so X over 27. So if I did the basketball player's height over the basketball player's shadow, that means I'd need to do the player's height over, Walter's height over Walter's shadow to stay consistent. So I would need to do 75 inches again over 24 inches. That would be consistent. I would be doing height over shadow equals height over shadow. I could reduce the 75 and the 24 by 3. You want to do that? Or do you just, since we're going to use our calculators anyways, don't worry about it? All right, we'll reduce it. We'll put 25 over 8. 25 is what 75 divided by 3, and 24 divided by 3 is 8. So now we're going to get 8x equals, and 25 times 27, I don't know what that is, so let's see what that comes out to be. 675 is right. Remember that. And then you're going to divide it by 8. So 675 divided by 8 is 135. It's got to be decimal or something, I think. Yeah, 84.375. Inches. So if we were going to say the basketball player is what height as far as feet and then height, feet and inches. 84 inches would be 7 feet.
Oh my goodness.
And 0.375 is going to be less than half of a foot. So it's probably about 5 inches. So it's probably about 7 feet 5 inches. Not really. 7 feet 5 inches would be a little bit tall.
Never been anywhere.
No, there's been, well, take that back. Manute Bowl, I think, was that tall. I think he was 7'5" or 7'6". Welcome. So, last one. Last one. Have you ever heard of the St. Louis Arch?
Yeah.
Have you ever seen a picture of the St. Louis Arch? Or ever gone to the St. Louis Arch? Okay, let me show you a picture of it then. Because it's pretty cool. The St. Louis Arch looks like this. And it's pretty cool at night when it's lit up. I've never actually seen it in person, but I have friends that have been there. You can actually go inside the arch. Go up. I don't know if you can go all the way to the top, but I know you can go up in the arch. You can go all the way around? Okay, yeah, so you can go all the way around the arch. So, it's pretty cool. But for our job, we want to find out how tall that arch is. This is a real life scenario here. Okay, this is going to give us the real height of the arch. Okay, so basically what it is Valerie walks 278 feet. So she's standing right below the middle of the arch. She walks 278 feet and she gets to the end of the shadow of the arch. So let's make a little notation on our picture that this piece is 278 feet. Okay, now it says Valerie is 5'8" tall. So she found out where the end of the arch was, and she backed up so that her shadow ends at the same spot that the arch's shadow does. And she's 5 feet 8 inches. 5 feet 8 inches. Do we want to do total inches? Total inches, 5 feet 8 inches. 68 inches, right? 68 inches. 278 feet. Let's put that into inches. 278 times 12. 278 times 12. 3336 inches. And what else do we know? That her shadow is 2 feet 6 inches. So right in here, this little amount from her to the end of the shadow is 2 feet 6 inches. 24 plus 6 would be 30 inches. So what would be a good proportion now to set up? Okay, wait, we need X, right? Oops. We need X, that's the height of the arch. Her shadow is 30 inches. So let's put what on top? X on top? X over... Okay, X over 68 would work, or X over 3336. You can do either one. We'll do arch over arch. We want to do arch's height over arch's shadow. So that'd be 3336. Let's move the X over a little bit so it looks a little better. Okay, so that would be one ratio. That would be arch over arch. Arch's height over arch's shadow. So what would be the next one we would have to use then? 68 inches would be her height over 30 inches her shadow. Her height over her shadow. So arch's height, arch's shadow, her height, her shadow. Those would be corresponding pieces. Alright, so let's solve this thing. You could reduce, but since you're going to use your calculator anyways, I'm not going to. 30h or 30x equals, and let's see, 68 times 3336. 226,848. Yep. 226,848. And then we're going to divide that by 30. Divide by 30. 7,561.6. 7,561.6. Now, how do I get that into feet? Divided by 12. So x equals, divided by 12, 630.1. So I'm going to round it to 630. 630 feet. is the height of the St. Louis Arch. No, but that wouldn't be any fun. This is way more fun. Okay, so let me show you the Google again. We'll go back to the web, and because I wanted to get it back to feet. Now, do you see Wikipedia here says that the Gateway Arch, they call it the Gateway Arch, it's 630 feet tall. We got it right. 192 meters. And you can actually read a little bit about it there and who made it and all that kind of stuff. I know, but that has the right number. That's the right number. 630 feet is what it says. Okay, so let me go back to here in case you didn't get it done. There it is, if you need it. Alan, you're killing me, man. You're killing me. I know, I didn't say you didn't. I just said you're killing me that it keeps doing that to you. It's like only like 3 or 4 people that do doing it on there? They're after history and all that stuff. For some reason, it's like messing it up. Well, I'm going to post it so you can fix it. That's what I would do.